Welcome back, ladies and gentlemen. We have some pretty cool stuff today. We're going to talk about factorials and combinations. Hopefully the factorials part is going to be easy peasy lemon squeezy for you. The combinations might be difficult lemon difficult because the formula is a little convoluted and kind of understanding what you're doing is a little weird, but I believe in you. I have a lot of faith in you guys and your ability to plug numbers into a formula. So hopefully it's not too bad. We are also going to make a little pit stop and talk about these things called permutations as well. These are like an easier version of combinations because there's less restrictions on them. But we'll talk about them. They're related to factorials. You kind of need them for combinations, but we'll get there. Okay. So let's start with a factorial. So let me read you this definition on how to do it, and then we'll do a couple examples right here. They're pretty easy. So to do n factorial, and remember n is just a fancy way of saying a whole number, meaning 0, 1, 2, 3, 4, etc. So n can be basically any positive integer or 0. So to do n factorial, the exclamation point is the factorial, do n times n minus 1 times n minus 2 times n minus 3 times so on and so forth until you get to times 1. So what this means is, let's say we want to do 6 factorial. This is 6 times 6 minus 1 would be 5 times 6 minus 2 would be 4, so on until we get to 1. So 6 factorial just means 6 times all the whole numbers below it until you get to 1. So that's not too bad, right? It's a nice short way to write this thing out. So if we do that, I wonder if there's a button on my calculator that does this. I'm sure there is on yours. If you spend some time looking around your calculator for the exclamation point, you might have to do like shift and then something, but I almost guarantee it's on the face of your calculator. But I don't have one of your calculators just sitting around to test that out. But it's not that bad to type out 6 times 5 times 4 times 3 times 2 times 1. So if we do this, you get 720. There you go. Easy, right? It's just multiplying. If you do 4, this is going to be 4 times 3 times 2 times 1. So I think this one is 24. 9, this is where you kind of get into the realm where you probably want to start trying to look for that button on your calculator. You could even Google it. Google the type of calculator. So look at it like, here's your calculator, right? There's a screen. Got some buttons on it. All right. Look at the top. You'll see the name of your calculator. If you have one of the ones you checked out from the school, it's like FX-G something something something. Google factorial and then the name of your calculator, and it'll tell you how to do it. So if we do 9 factorial, it starts to get pretty big pretty quick. This is equal to 362,880. And then we need to talk about 0 factorial. This one is kind of like special, right? Because 0 factorial is that 0 times 1's not less than 0. Do you know what I mean? It looks kind of weird because people learn factorials this way. I watched a video. There's a wonderful video on a YouTube channel called Numberphile. And if I might even put it in the description of this video. That might be the professional YouTuber thing to do. But they have a video on why this is what it is. And both of them seem like it's that way because mathematicians say so. You know what I mean? I'm sure there's some really good reasons why it is what it is. But this one, you just kind of want to know. It's 1. Okay, cool. There you go. Now you know how to do factorials. Anything over like 9, you probably want to go find the button on your calculator to make your life easier. But I'm not your mom, and I'm not going to tell you what to do. All right. So now we need to talk about something that's a little more complicated. We're going to do combinations and permutations. Okay. We're going to start by talking about permutations because these things are a little bit easier to understand than combinations, right? So let's say we have 3 things. We're going to ignore this question for right now. Don't worry too much about it. That's going to be for the combinations. Let's talk about permutations. Let's say I have a red triangle, a blue square, and a green circle. I want to know how many ways can I arrange these? How many different ways can I line these up? So the question for permutations is how many ways are there to arrange don't mind the way I spelled that, to arrange these objects. Okay, so this is the question we are asking. So let's look, right? Let's just count them. So that's one way. Okay. Can I copy these things? Oh, let's just make them infinite cloners. That'd be cool, right? Okay. So let's just count them, right? That's one way we could do it. So what if I took these and switched them? All right. So that's a second way we could arrange them. Okay. So if I switch them back, I'm back to this way. So now we've got to move the triangle out of the front, right? So let's move the triangle to the second one. Let's put the square in front this time. Okay, so I've got the square in front. That's 3 ways. Okay, we'll flip these 2 again. That's a new way we could do it, all right? So put the triangle at the back, the circle in the middle. That's our 4th way. So right now we can see, oh, there's 2 ways with a triangle in the front. There's 2 ways with a square in the front. There's going to be 2 ways with the circle in the front as well, right? So we got circle in front, triangle, square, and then we've got circle in the front. Whoops, come on, circle. Circle in the front, square, triangle. Okay. So there are 6 total ways. Okay. One way we can think about this is how many things are there here? There's 3 of them, obviously. 1, 2, 3. So we want to think about how many choices do we have when we're arranging these things. So I've got 3 spots that I can fill up, right? I've got the first spot, the second spot, and the third spot. And I'm not going to repeat any of my shapes. So how many options do I have in this first spot? Well, because the first spot, and I haven't picked anything yet, there are 3 options. So there's 3 different things that could go there, right? Now, how many options do I have for the second spot? Well, I've picked one of these, right? So that means one of them is gone. That means there's 2 shapes left. And if I pick a shape for the middle, then there's not an option here. I have to use whatever the remaining shape is. So we have 3 different ways we could do this one. And then each of these 3, right? I could do triangle, square, or circle. Each of these 3 ways has 2 ways to organize the remaining 2 things. So we multiply them. Oh, wait, what is 3 times 2 times 1? That's 3 factorial. Oh, crazy. What? It's almost like factorials are related to this. So these are what are known as permutations. Okay, it's different ways you can organize this stuff. So if we do something a little fancier, let's go back and talk about this original question we've got here. I'm going to get rid of these. I don't think I need them anymore, right? Get rid of these infinite cloners. Infinity scares some people. Let's get rid of those. We don't need those. Delete. Okay. So we have 5 people. Let's say 1. Let's get different color people. We don't see color here. Actually, we see color and we appreciate the variety, right? So we have 5 different people. What color am I missing? Black. Okay, cool. Beautiful. We've got a beautiful array. So we have 5 different people here, and they have 3 chairs that they could sit in. Let's see if I can draw a chair. So we've got, oh, that's hideous. Oh my gosh. Redo. There you go. That's pretty ugly too. Let's try that one more time. What do chairs look like? I need a chair to look at. What do chairs look like? Is that a chair? I'm a little happier with that one. Okay, sweet. And it's even one chair. How tight is that? All right. Copy, paste, paste. Okay, we've got 3 chairs. We don't really care who sits in what chair. It's not super important. So we want to talk about how many different ways can we put these 5 people in these 3 chairs. So let's think about our options, right? How many different people could we put in this first chair? Well, we could put 5 here, right? I could put the purple person, the red person, the blue, the green, or the black person in this first chair. So we have 5 options. Wonderful. So if I pick one of these people to go in the chair, then how many options are left for this one? Well, one of these people got the chair. So there's only 4 of them left not sitting. So then we have 4 options here. And then obviously one of them sits down. And then we have 3 options left. So if I want to know how many people can sit, how many ways are there for 5 people to sit in 6 chairs? It's 5 times 4 times 3. This is not quite a factorial like we just saw, right? It's not a perfect factorial because we're missing the times 2 times 1. This is what a real permutation is. There's a formula for this, actually. We can get this out of factorials, and I'll show you how. So we have 5. So let's start with 5 factorial. This is 5 times 4 times 3 times 2 times 1. We want to take off the times 2 and the times 1. Ooh, yeah. So we need to divide this by this chunk here. Okay, so that's 2 factorial, right? 2 times 1, 2 factorial. So if you divide this by 2 times 1, this cancels with this, and then you have the thing you want. And you're going to say, all right, how do I know this is 2 factorial? Like, where does this come from besides I just want those things to cancel out? This is the number of options you have, 5, minus the number of like places to put those options. 3 is 2, and then you just factorial that thing. So the equation for permutations is n factorial divided by n minus, let's call it r. This is like the number of places factorial. Cool? So that's permutations. This gets a little weird though. I think we're going to pretty much call it there, right? So that's permutations. This I'll say one more thing, and then we'll move on, and then I'll teach you the formula for combinations. And you'd be like, Barton, why didn't you just start there? Why are you forcing me to learn all this convoluted people sitting in chairs math? This is dumb. Just teach me the formula so I can plug it in. And you've got to remember, there's like one of you who cares about this. So I'm teaching to that one person right now. That person, I got you, fam. I'm not going to disappoint you and withhold spicy math from you. You deserve spicy math. And the rest of these haters can just, bugger off. So, let's talk about one just scenario. I'm going to point it out to you, not do any more spicy math, and I'll hit you with a formula. Okay? So, let's say the purple person sits here, and then the blue person sits down, and then this black person sits down. That still feels so inappropriate to say. No, it doesn't. Never mind. Black's a color. They're just colored people. I don't get why that would be weird, right? So, if I have a purple person sit down, then a blue person, and a black person sit down, this is one way to permute, or one variation of people sitting down. If, however, the black person sits down after the purple person, and then the blue person sits down, these get counted again when we do these permutations, when we use this spicy formula right here. However, does it really matter what chair they sit in? No. So this, do we want to count this as being different than... Whoops, I moved the chair. I stole that dude's chair. Do we want that to be different than that? No, not really. So we need to figure out a way to not count this as a separate thing, because these three people are still sitting. It doesn't... Who cares, right? It's not like we're playing musical chairs and there's like this person wins $1 million, and if you sit in this chair you win $100, and then if you sit in this chair you win a house, right? It doesn't matter. Everyone wins an apple pie if you win musical chairs. So combinations, the thing that separates combinations from permutations, this one, you don't care about order. And this one, you do care about order. You're saying, well, there's a difference between those chairs. So we need to count purple then blue then black as different than purple then black then blue. So combinations, there are slightly less combinations than there are permutations. That's the only difference, is do you care about order or do you not? So now that you are all super frustrated with me talking about this for 18 minutes without actually teaching you anything, let's go learn the formula and let's figure out how to do your homework problems. Okay, so let's talk about notation first. These things are all the different ways you can write combinations, right? This is like the formula for combinations. But they all mean the same thing. What this means is, from our last example, this is the number of people you have, and this is the number of chairs you have. The way you would say this out loud is n choose r. So it's if you have n number of things and you pick r of them, how many different possible sets of things can you get, right? You have 5 people and they get to choose 3 different places to sit. How many different groups of people can you make if we count them all, right? That's what you're doing. So this, and this weird thing all mean the exact same thing. It's just different notation depending on different contexts, right? This one will show up in your next lesson as some coefficients, but you're fine. You're a big kid. You can handle it. So I think this is the way tonight's homework will look. So, I just want you to be aware in case some years down the line it's different. This is how the problem is set up. This is the formula you use to solve the problem. Notice this is the permutation formula. That's that permutation formula we found right here by trying to count how many different ways people can sit in chairs. To turn it into the combination formula, you just put an extra r factorial on the bottom, or the number of chairs factorial on the bottom. Okay? So let's go ahead. Let's go take care of this business. Let's do a couple of examples just to build your confidence. You're going to see this is a complicated way to do a not complicated thing. The problem is you've just never cared how many ways people can sit in chairs before, but now you sort of care because it's on your homework. So let's go look at some examples. Here's our formula. I was nice enough to bring it over here for you so that you don't have to go look for it again. And remember, this is n choose r. So we're just looking at that first number and the second number and then plugging them into the formula. And I'm going to show you some ways that we can simplify this a little bit. I'm going to do it maybe the hard way on this. And then the rest of the time, we're just going to throw it into the calculator. And hopefully I can find the factorial button on my calculator so that I don't have to do this one on like the difficult way. But, maybe. Okay, so looking at our first example, we want 12 choose 6. So n is equal to 12. And r is equal to 6. So we're going to just plug these into this formula here. So on top we have 12 factorial divided by 12 minus 6 factorial. So you want to do the subtraction before you do the factorial. Times r factorial. So 6 factorial. All right. I'm going to do this the long way just to show you maybe a couple tricks that'll help you simplify. It'll come in really handy for this one so you don't waste a bunch of time typing stuff into your calculator. But then we're going to definitely use our calculator on this middle one. So 12 factorial is 12 times 11 times 10, and you're going to have to just give me a second to write all these out because, of course, I didn't have the foresight to put this down ahead of time. But that just makes for good content. Someday when I'm a famous YouTuber, I'm going to do this intentionally to fit more ads in, right? So this is 12 factorial. 12 minus 6 is 6. So this is 6 factorial. So we're going to have 6 times 5 times 4 times 3 times 2 times 1. And then we have another 6 factorial. So times the same thing again, right? And you're going to have to just, bear with me. Don't worry. This is the best days of your life. You want them to last as long as possible. So the first thing you want to recognize is that this chunk here is the same as this chunk here. Sweet. So this thing cancels with this thing. Cool, right? So that just makes it a little bit easier for you to type in, right? So you can just do 12 times 11 times 10 times 9 times 8 times blah, blah, blah. Type this in and then divide by 6 factorial. That might make it a little easier, but honestly, if you can find that factorial button, you're in good shape. So I went and found the factorial button on mine because God knows I'm not going to type this whole thing in, right? Like, I'm not about that life. So I'm going to type it in, and you're going to wait. You're going to sit there very patiently while I do this. And then, we'll have a good time with it. 6 factorial. All right, and then you have to sit and wait for your calculator to chug. It's like thinking real hard. So when you do this, you should get 924. Okay. All right. That's how you do the first one. I really recommend finding that factorial button. You could probably do this on Desmos. Go to Desmos and do like 12 factorial. I bet it'll tell you the answer. If not, you can just type 12 factorial equals into like your URL on Google, and Google is a calculator itself. It'll tell you what this is. So at the very least, you could type that in, and then you could go ahead and just like write it down somewhere. So this is 479001600. Write that down, and then that's the top. And then you can figure out what 6 factorial is. 6 factorial is hidden in my calculator for some reason. That's 720. Oh, and then we have another one, so times another 720, right? So you could times that again. And then you could just take this number and divide by this number. It'll give you 924. So today your homework's going to be crappy only because you have to figure out how do I type this thing into a calculator. No matter what, it's going to be kind of a lot of work. But you're big kids, so I believe in you. Okay. Let's talk about, let's just do this one to get out of the way. So this is 52 factorial divided by n minus r. So again, this is n, this is r. Subtract, so 52 minus 15. I would use a calculator just because, you know, I'm not very smart and I'm not very good at subtracting in my brain. So use a calculator if you know you struggle. There you go. This is what you're putting in your calculator. So then you go grab your calculator. You're going to do your 52 factorial divided by 37 factorial. Whoops. Back up. 7. There we go. Times 15 factorial. Oh my gosh, what an absurd number. You're going to get some really big numbers today. I think you have something as stupid as this on your homework. What we get when we type this into the calculator. This equals, and you're going to have to give me a moment here. There you go. That's how many different ways you can organize 52 things by getting a group of 15. This is how many options you have. Crazy, I know. All right, now this one we're going to do by hand. And you're going to go, Barton, please, anything but that. Please don't make me do that. Why? Listen, Barton, what did I ever do to you? But this one's nice because it simplifies by hand really nicely. Look, so n is 17, r is 16. So let's plug them in. So we have 17 factorial over 17 minus 16. This is 1 factorial times 16 factorial. Okay, 1 factorial is 1. So times 1, this doesn't do anything. Right? And then let's look at this. 17 factorial is 17 times 16 times 15, yada, yada, yada. On the bottom, this is 16 times 15 times yada, yada, yada. So this 16 cancels this 16. This 15 cancels this 15. This yada, yada, yada. Whoops. Did you guys not see the pen? So that yada, yada cancels that yada, yada. And then you're left with 17 over 1. So this is equal to 17. So anytime n is only 1 bigger than r, your answer is n. Fun fact. But I think I've held you hostage long enough. So if you're impressed with my ability to count ways to put things in order, that's not what I was going for at all. Like, you shouldn't be. This is pretty easy high school level math, but, you know, practice. If you need help, if you have questions, let me know. I understand that people sitting in chairs is kind of a weird idea, but, you know, let me know about it in the WebEx below. I'll see you guys next time.